Wait for it. Okay. Is it recording? Okay. So there's 3 reasons why we're going to spend the next couple days on these limit definitions. That's what it's called, what we're doing. One is because, frankly, you need the algebra practice. You all do. Okay? Number 2, because it's a building block for the rest of our year. And number 3, I've found that if I just give you a list of rules for the derivative rules, and I say memorize this, it's really hard to do that, right? But if I prove to you where they come from, then it makes the memorizing of the rules much easier, okay? So we're gonna practice our resiliency the next couple days with some heavy algebra, okay? But you can do it. The big picture is scary, but each step, the algebra is doable. Foiling, factoring, common denominators, things like that. You can do those things, okay? So just stay with me. Now, the first thing we're going to do is we're going to go ahead and we're going to define what I'm even talking about. Basically, we're going to find our very first exact derivatives today, okay? So we're going to do it in general so that it works for any function, okay? So if this is just x and this is some random f of x, I'm just going to draw a random shape. So it's not a parabola, it's not an exponential, it is any ambiguous function, okay? I have some ambiguous function, okay? And I'm wanting to find, okay, sorry, I got to change colors. I think I've been told green doesn't show up very well on the videos. Okay, so I want to find the derivative here at some ambiguous a, okay? Now, if I want to find, not estimate, find the derivative there, I have a problem. Do you guys see the problem? How do I find an instantaneous rate of change, so a slope of something when I have only one point, right? My slope formula I've been using forever, y2 minus y1 over x2 minus x1. I need a y2 and a y1, right? I can't have 1 point. I need 2. You with me?
So you need to graph the exact slope.
If I want the exact derivative, then I need the exact slope, right? So all I'm asking you to realize right now is that is a problem, right? Okay, you agree with me? That's a problem?
Yeah.
Okay. Okay, this coordinate point right here is the point A, comma, f of A, right? It's the only point I know on that line, okay? So now what I want you to do is I want you to pause for a minute, and I don't even want you to write this down. I just want you to think about what I'm saying. I'm going to describe to you something called a math paradox, the paradox of 1, okay? So again, I don't even want you to write this down. I'd rather you just watch, okay? So if we're pausing on this, 1 minus 0.1, oh no, that's not good. 0.9, I mean, is 0.1, okay? 1 minus 0.99 is 0.01. 1 minus 0.999.001, fair? 1 minus, do you see the pattern? If I did this many 9s, 1, 2, 3, 4, 5, 6, 7, then I'd have 6 zeros and then a 1, right? So then, what's that? Just think about it for a second. What's the little line on top of the 9 mean?
Oh, no.
Forever. So what do I have? An infinite number of zeros with a 1 after? Do you realize that that is very, I can't think of the word I'm trying to think of. Not oxymoron, but is that the right idea?
It's impossible.
Insignificant, counterintuitive, that can't happen, right? I can't have an infinite number of something and then something after it. Does that make sense?
Yeah, because then it defeats the point of infinite.
It defeats the point of infinite, right? So to mathematicians, okay, that's a true statement. How weird is that? Because their difference is infinitely small.
Just like
Their difference is, there is an infinite difference, right? Infinite number of zeros. There's no difference between them, here and then here.
so So is it kind of like how we approach zero? We just say like is approaching zero instead of because
It's getting
it
so
never gets to zero,
close
but
to it.
We just say it's like
Yeah, that's exactly what it is because we're seeing you're talking about a horizontal asymptote, right? So we're getting so close to that number, to that zero or that horizontal asymptote, that the difference between them is so insignificantly small, it's like it's not even there, right? Okay? Yeah. Same? Okay, good. Yes. Most mathematicians would disagree with that statement. Getting infinitely close to something eventually means they are the same. Because their difference is an infinite zero. Like if I have infinite zero, right? Then there's no difference. It makes sense, but it doesn't, right? It's like one of those things when you stare at a word too long and it's like, I stare at this poster all the time up here, the word today, and sometimes it'll be like fourth period on a Friday, and I'll be like, that's not how you spell today, right? Like that's kind of how this is, right? It kind of makes sense, but if you jump too much into it, it's gonna kind of blow your mind, or you're gonna love it, and then you should go into math, please. If you start wanting to think about this more, go talk to Mr. Jones, and then go into math, please, right? Because that's good. But that basically from this whole point of this, what I want you to understand is mathematically, okay, we can get to the point where two numbers, their difference is so infinitely small, it doesn't exist. So it's basically like these two different numbers, there really is no difference, okay? Is that okay?
Would it be the same thing with 1.1, or is that different? That's different.
Well, it'd be 1.0000000, and then eventually a 1, right? But that's, even that is hard to show because how do I write the bar over the 0 and then a 1 after? Again, that's counterintuitive. You can't have anything infinite with something after it. That can't happen.
Kind of like you can't limit from infinity from the left or something.
Maybe. I don't know.
You have to, like,
That's okay, I want to move on to the algebra, okay? But what I need to get from here, it's called the paradox of 1. I know it's weird, that's why it's called a paradox, okay? The paradox of 1. We can get to the point where two numbers have such an infinitely small, insignificant difference that they're the same number, okay? So there's no fix. So let me apply that to the problem here. You can start writing your notes again, but this is one of those ones I'm like, just watch, okay? So this here, the reason I bring that up is there's no fix to the problem of finding the slope with 1 point on the line. I can't fix that, okay? But what I could do is I could get so close to this number that I'm the same as it, okay? So in order to do that, what we're going to do is we're going to define a distance, h. H is the distance, okay, away from my point of tangency of these points on a secant line. So this right here is a minus h, that x coordinate, right? And this x coordinate is a plus h. Guys doing okay? What's the y coordinate of this secant point? Yep, Jackson? Nope. This is ambiguous. So close, not f of a minus h, right? This is its x coordinate. So whatever this is plugged into f. So the coordinate point right here is the point a minus h, f of a minus h. X, y. Fair? So I'm defining a new variable h. That's the distance between the point of tangency and the secant point.
So is it the same thing for the other one?
Yep. So this here is my point of tangency. No, ignore the last 5 seconds. This here is the coordinate point at the end of this secant line. And this one is the coordinate point at the end of this secant line. We're doing okay?
So how is this like infinitely close to
It's not yet. It's not infinitely close yet. Right now, I'm just using a secant slope to estimate a tangent like we've done for the last month, right? We're doing okay? How are we doing, okay? Okay, guess what?
Wait.
Find the slope. We're going to try that with your neighbors. Find the slope of the secant line. Be careful, we have no idea what type of function f is, so be careful with how much you try and simplify. Okay, so take a second and try and find the slope between those 2 points. Monster. Knox puzzle piece on the record doesn't pick it up for just to get lost. So I'm defining h as a distance between here and here. So if this x coordinate is a, the distance to the left of it is like taking the distance away. What if my h was 2 and this was 3? Then a minus h would be 1, right? Because I go 2 to the left or 2 to the right. Because I have to do it all ambiguous. I can't assign numbers to it.
Yeah.
So I'm saying that this will work for any A, any H, any F.
It has to always be applicable.
Yeah. Because I can't find the slope. If I'm finding exact derivatives, which is what our unit is now, I can't find the slope of this tangent line because there's only 1 point. So right now I'm making a slope with a secant line.
Oh.
Right? And I'm finding some way to define the secant line ambiguously. That's what the H is, the distance between the secant and the point of tangency. Right? How much simplifying can you do on the top? None. You don't know what kind of function f is. You can't distribute the f, right? You can simplify the bottom though.
Yeah, 2h.
Good job. 2h is correct.
So we can't.
No. What if f was a log? Can I distribute a log in? No, right over a plus sign. In fact, almost every function you cannot distribute the f in. So there's nothing I can do. So all I've done so far, right, is y2 minus y1 over x2 minus x1, right, slope, rise over run, right? And then distributed a negative and combined like terms. Is that okay? Okay, so let's stop here and I'm not moving on until I get at least one question on what we've done so far in the process.
So
I'm not moving on until I get at least one question. There's no way you all understand this rocket science perfectly. Not my first rodeo.
for some reason,
Yeah. H is a new thing. It's a new thing, okay? It's a distance between my secant points and my point of tangency. So it's something brand new I'm just defining today. So it's the distance between my secant endpoints and my point of tangency. So that's why I'm subtracting it to go to the left of my point of tangency and adding it to go to the right of my point of tangency. Okay? Yes?
do you define h?
Well, Isaac Newton defined H. I don't know if I understand your question.
Like,
Sorry.
is h going to be the same both sides? The distance?
Okay, good question. Eventually, it's not going to matter if H is the same on both sides, but I already have enough variables in the situation. I don't want to add another one in, right? There's already so few actual numbers. So his question was, does H have to be the same on both sides? No, but why would I want to have like another thing in here, right? I already have too much. So if they can be the same, why not, right?
Yeah.
Okay,
So
what else?
You said Isaac Newton defined H?
Yeah, he's the father of calculus.
Yep, Isaac Newton does all this.
No, meaning so he he knows the number of H.
No, H is not a number.
So H, I don't know, so like, do we ever?
It's a concept.
Yeah, it's not like a constant like k equals -6.
No. Ignore what he just said. Okay. Now, hold on. Right now, you guys stay with me. Stay with me. Just stay with me. Stay with me. Derek, you with me?
Yeah.
Okay. So right now, this is not the derivative. This is still the ARC, the average rate of change, right? Because this is the slope of a secant line. So that's my average rate of change, my ARC, right? If I wanted to make it an estimate of the derivative, I want you to think, how have we been doing that in Unit 2, right? How have we been finding the best possible estimate of a derivative in Unit 2, our last unit? We find the slope of the smallest secant line possible, right? You with me?
Yes.
In fact, what if we found a secant line that got so infinitely small
That it was pretty much a tangent.
that it's basically the tangent?
Uh,
To do that, okay, what function that we've learned about this year can allow us to look at things as they get infinitely small? A limit. So as soon as I put here the limit of this function as h goes to 0, so the distance between these points and the point of tangency goes to 0, guess what? This is now my slope of tangent.
Wait, why does it go to 0?
Because that's the distance between the secants and here. So if I want these to get infinitely small, infinitely closer to A, I need that distance
okay.
to get infinitely tiny. Right? Or my IRC. Or my F prime at A. Okay, process that for a sec. Okay? It's tough. This is tough stuff today. Okay? That's good.
It's weird.
Maybe you guys are just so happy to be done with limits and graphing. I don't know. Okay? Now, well, let's just stop here. What questions do we have so far? Anything so far?
So because of the
What?
well, because limit approaches 0, or like H approaches 0, that changes the slope of the tangent.
Yes, because it's making the secant line as close as possible to the tangent line.
So it's essentially the IRC.
It's essentially the IRC as soon as I look at this as my H gets infinitely small. Okay? I'm going to make a big connection here next, so I need to make sure this makes sense. Here,
So would that work with like anything if you're just
any function, any value A.
okay.
And H is never defined with a number because we always are looking at it as it goes away. So this works for anything as long as the function is differentiable at that A. What does the word differentiable mean?
Has the derivative.
Has a derivative. So if A is the function's vertical asymptote, this isn't going to work, but that's because it doesn't have a derivative. As long as the derivative exists for that function at that A value, this will work.
So what if it's a whole?
That doesn't have a derivative. It must be continuous to have a derivative.
So in order for this to work, f of a must exist.
Yes. But not every f of a exists. Vertex of an absolute value, right? This isn't going to work because the vertex of an absolute value does not have a
Or
derivative.
is it the
So f prime of a must exist.
F prime of a must exist for this to work, and it will find it exactly. Not very easily, but exactly. Okay? Yeah.
Does that mean that like can jumps have?
Jumps cannot have a derivative. Yep.
So any discontinuity.
Shouldn't the limit be H approaching A, not, like, why is it 0?
Because H is the distance between this point and this point. If H approached A minus A would actually be over here. It'd make the secant line actually bigger. Right? Because this is not the x-coordinate H. H is the distance between these two. We don't want the distance between these two to become A. We want it to become 0. Okay, let me try it with numbers to see if that'll help. If A is 3, like on a number line, right? And let's say the distance between my points was 5. So this is 8, because this is 5. 5, so this is A plus H, and this is -2. My brain is melting. Okay? We don't want H to become 3. We want H to become 0 so that these get closer to the 3. Because H is this distance between them.
So 3 is theoretically 0 in this part.
Oh, okay. Yeah. that
Make sense? Okay.
So is 3 theoretically 0?
No. 5 is what we want to be 0. 3 would be that I'm trying to find the derivative there. Okay? Okay, I think we should move on to an example, and I think it'll help solidify it, okay? So now, you're probably going to want 2 colors for this. Isabella, do you mind? I'm sorry. You guys, I need you to move way over. Isa's head's going to be right. And unfortunately, these are those math problems that, like, take a whole page, so they take a whole whiteboard, you know what I mean? Hey, do you guys remember how your math teachers in previous years were always like, this is my Billman voice. Actually, I shouldn't do that. I'm recording, just kidding. Well, I mean, it was going to be the same voice no matter what. But they always go, you have to show your work because eventually, right, you're going to get to the point where the problems are so long, if you make one mistake, you need to see every step. And your problems will be a page long. That's going to be what today's like. So show all your work, and you're going to need 2 colors. Okay? So, we got it. We have here.
Wait.
No, nobody said matrices ever. Past 1985, no one has said the word matrices. I know, they're just so obsolete. I don't know why they teach them.
I'm so worthless.
Yeah.
Yeah, I don't know the real
We're never
world
gonna use
applications.
matrices?
No. Matrices is how to solve upper level systems of equations, but the problem is that it's just for the good practice of it.
No.
I don't want them on the ACT. Take matrices off the ACT.
Are they on there? Yeah. Well, then you can type them into your calculator pretty easily. Let's focus on what we're doing here, though, okay? This is our definition for finding exact derivatives, okay? Where I want us to start, though, is I want us to start with what we did last unit, okay? So I'm going to give you some function here. All right, let's go.
We're gonna fall wrong on the other side here.
How did he do it?
Bro, I don't even know if it was like all him. Probably not.
But still.
Let's not worry about that, and let's worry about practicing our algebra.
This is in history.
Staying with me. The history of math is very
No, it is
interesting.
interesting.
I think so. Okay, so I'm not going to tell you what function this is yet. Okay, I just want us to take a estimate here for what f prime of 1, 2, 3, 4, 5 is. So if we were doing this last unit, right, you just take a guess and you tell me what is about f prime of 5. So what's the slope of that tangent line at 5? 3? Okay, let's go with 3. Right? It's a positive steep slope. That's fine for an estimate. Okay? So now what we're going to do is we're going to go through the math and we're going to find what it is exactly, and we're going to check our estimate. Okay? So this is where the first step is almost always the hardest step because it's the weirdest step. Okay? So the first thing I'm going to do here is I'm going to take my limit definition of my derivative here, and I'm going to plug in my a, which is 5, right? That's the x value of the point I'm trying to find the derivative of. So I'm looking for not about what f prime of 5 is, but what exactly f prime of 5 is. Okay?
Why does it say f prime of 5 is approximately 3?
Because that was our guess. Now we're going to find it exactly and see how close our guess
the
is.
slope.
The slope. Yeah, not the value, the slope.
I'm like, wow.
Yeah.
We'll never be 3.
Okay? Now, okay, we're going to take a step back to Sec 2, Sec 3, okay? Yeah, well, I mean, we just did slope earlier. I mean, that was like Sec 1, right? Okay, this is the part that's going to look a little weird, okay? But you can do it. It's a function composition. If I'm giving you the f of x, because now I'm going to give you the equation, okay, is 1, 2, 3. Okay, that's the equation. Okay, but I need to find f of 5 plus h and f of 5 minus h. So think back to Sec 2, maybe some of Sec 3, but whatever is in here in the function notation, right? Okay, guys up here, this is the hard part. Okay, this is what goes in for x, right? If this was just a 5, wouldn't we put 5 minus 3 squared, right? Okay, so this is what's going to go in for my x. When you take your function composition, right, you're taking what it wants you to input and replacing the x. We doing okay? Well, should I stop for questions? Okay.
Wait, so the point right there is 5, 3?
No.
No.
The point right here is 1, 2, 3, 4. It looks like 5, 5. I'm saying that the estimate for the slope of that is about 3.
So why are we minusing 3 in that equation?
Because that's the equation of this graph. This parabola here is y equals x minus 3 squared plus 1.
Oh, so it's like y equals m.
This 3 and this 3 are different. They don't have anything to do with each other.
Oh my god.
This was our guess for the slope. This vertex is at 3, 1. I just did an easy like right and up shift so I could write an easy equation.
Okay.
Does that make sense?
Nothing.
Yeah. Okay, good? Okay, so here, I'm hoping eventually you'll be able to do this without all of this, right? But what we're doing here is we're making this general definition that we have here that works for any a and any function specific to this scenario, right? So I have now...
Oh my gosh.
Just keep swimming. Just keep swimming.
I see. I see.
Do my homework at home. Try. No, you're not.
That's why there's only
Hey,
3
if you cry, you
problems.
gotta cry. It's okay. Just don't give up. Sometimes I gotta cry to get through my email. Right?
Oh gosh, okay.
It's okay. It's okay. We're okay. Right? We can do it. Now, from here on out, it's no longer the calculus, right? From here on out, it's foiling, PEMDAS, stuff I know you can do. You might hate, but I know you can do. Okay? Yeah, Jackson.
Can I check out my answer?
Not yet, bro. Hold your horses. Okay? So what am I going to do first?
Group together,
What?
common,
Terms? I'll take it.
yeah.
Parentheses, right? 5 minus 3. 5 minus 3, right? Okay, so then I've got my I'm kind of done with the two colors. That just helps with the function composition on the first few problems. Because now the input's not the same as this stuff, just FYI. Now what am I gonna do?
Oh,
You have to,
Distribute. Now I gotta distribute.
Wait, so why does f prime of 5 equal 2 things?
F prime of 5 does not. The slope of this secant line between these two, as it gets infinitely small, is its derivative. This is, when I'm done simplifying this, I'll get one value, not two.
Right, that's what I.
So would you put the
But why does the one on top not have the minus 3 plus 1?
Well, that's still general with F. Now I've plugged in my equation for F.
Just do like
Oh,
So
okay.
this is still general from here. Now I'm gonna, so first I plugged in A, then I plugged in F. Now I'm gonna start my PEMDAS.
And if this were any function, you would just plug in
The
that
new
equation.
function.
So like if it was an absolute value, that's what you would plug in there, then we're just plugging in
A
for
specific
text
equation.
for this problem.
So here I plugged in A, here I plugged in F, now I'm going through PEMDAS.
Okay. thank you.
Okay? Okay, now I'm gonna distribute. Let's not lose our math skills because this is hard. You can distribute. Right? You do not distribute exponents, right, my friends?
No, you do not. Doing a new what's it called? Parentheses.
So I took these parentheses and I realized I don't distribute exponents. That's how puppies die, right? I have 2 of that factor and I multiply together. I'll show the box over here and I'll show arrows over here.
What do you mean that's how puppies die?
I meant what I said, bro. I don't care how you distribute, just distribute.
Wait, can
You guys will check all the answers together. Okay? I'm excited that some of you guys are getting ahead on the algebra. That's great.
You hate the puppies, that means you hate the smell of them running. Whoopsies.
Oh my gosh. Okay. Can I do 2 things in one step or are we going to have a meltdown for the next one?
No.
Can I do 2? I'm going to combine the 4 and the 1 and distribute a negative in one step. Is that okay?
No.
Okay. Oh girl, we are just beginning.
Oh.
It's only just begun. I don't know any other words now. So tough. You guys are doing great. We are practicing our algebra and resiliency in addition to learning the concept today. Okay?
Oh, I kind of
Now I have to
You're done practicing. A lot of people hated the graphic stuff we did the last couple units, so I'm glad you like the algebra. Okay, hold on. Now what? Now what? Now what?
I didn't do that.
Now you
Combine like terms?
Yes.
0,
Just cross it out.
right? 0. So I end up with 8h over 2h. Now pause. I don't want you to move on from here. I need to make a big unit 1 connection. Are you ready? Hold on 1 second. Why did we even, don't worry about that yet. I don't want you to get lost in the algebra and forget what we're actually doing, okay? I want to make a big connection before I give you the answer to our unit 1 from limits. You guys with me? Is everybody with me? Okay. Why the heck did we even do any of this, right? Because didn't I just spend a whole unit evaluating limits, right? And actually the first thing I would actually do when I would evaluate a limit is I'd usually plug my value in to see what happened, right?
Yeah.
Well, if I look at this over here, if I make h0 over here, do you see how I end up with 0 over 0?
Yeah.
Okay, I actually would have ended up with that even over here. If I make h0, I get 2 squared plus 1, okay, minus 2 squared plus 1, right? 0 over 0. Hold on, let's process this. Back in unit 1, like August, early September, when we did limits, what happened in a limit when I had a 0 over 0? Ben? Indeterminate form. That's a very fancy word. What does that mean though? What did 0 over 0 mean? Graphically, what did it mean? Uh-oh. You're going like this, Denali? What does that mean? Yep, it's a whole. 0 over 0 meant a whole, right? If it was like a number over 0, it was a vertical asymptote. 0 over a number was 0, but 0 over 0, that indeterminate form, meant a whole. Always, sometimes, or never does the limit of a whole exist. You remember?
The limit of a whole always exists.
Always. So here's the problem, okay? Again, just watch. Don't write this down, just watch. It's not worth the time writing this down. Back in unit 1, I gave you problems like this. Limit as x goes to 2, x minus 2, x plus 2, x minus 2, x plus 1. If you plugged in the 2, you get 0 over 0, and then you were like, oh, it's a whole. So I have to factor and cancel out a common factor, right? And then I got rid of the divide by 0 error so that I could then just now plug the 2 in, right? And I end up with 4/3 for this one. That's that just review of unit 1, right?
Yep.
Now we knew to do that because the limit of a whole always exists. So I had to perform some algebra to get rid of the divide by 0 error, okay? So even though we didn't realize it, we're doing the same thing here. It's just that the algebra was a billion times worse, right? But what we're about to do right here is eliminate the divide by 0 error. Just like what we did here. You with me? Barely, maybe barely with me. Maybe after you watch the video a few more times with me, right? This is a tough lesson. This is probably our hardest lesson in the whole semester, I think. Okay? So here I end up with f prime of 5 is my limit as h goes 8 over 2, 4. There's no more h to plug in, so as h goes to 0, guess what?
It approaches 4.
It is 4.
It is 4. Just
Our estimate was pretty good. I'm pretty happy with that estimate, right? Now hold on. Hold on. I want us to go back to the general one. So no matter what A is and no matter what F is, let's go back here. If I tried this limit from the beginning, right? H goes to 0, f of A minus f of A, 0 over 0. It will always be a whole. It will always exist. Right?
Yes.
So we're always looking for the algebra that will allow us to get rid of this divide by 0 error. With me?
Yeah.
Okay, these algebra problems are forever, right? So I want to give you a way with your graphing calculators to check your work. So if you don't have your calculator today, that's okay. Maybe write down the button steps. But real quick, get out your calculator before I have you guys try one of these on your own. Okay?
What?
Why did
That was the random one where I was just reminding you of how we did hold. 2? 5 minus 2.
we just ignored the H? Oh, because H is going to 0.
No, we ignored the H there because it's not a like term.
Understand why they exist.
I added these like terms
Oh,
together.
wait, okay.
Yeah. Okay.
I'm just a little slow.
Does anyone have something that's not an 83 or an 84? Oh. You have Casios are a little different. That's okay though. Everybody start. That's not gonna graph. Okay, so for 83s or 84s, go to your y equals and type in our equation. Okay.
My thing has not been graphing.
Now, if you have a Casio, before you type in your equation, raise your hand so I know who has a Casio. Okay, good. So if you've got a Casio, yours is actually easier because you only have to do this once. Open up a graph and go to your setup. Okay, open up a graph. Again, this is for Casios right now. I'm talking to Casios. 83s and 84s, you should be typing in your equation and resetting your window. If you don't have your graphing calculator with you today, maybe write down the button steps. Okay?
Which equation?
Okay, the equation for the problem we're doing.
I don't know which equation.
I think there's 5. How do we even
The equation for the parabola.
Oh.
Oh,
Okay. Casios. Okay, we're back to Casios. Scroll down to like the 5th one down. Do you see where it says derivative off? Click down there and turn on your derivative. So you should be in your setup for Casios and change it to derivative on. Did you go into your setup? Okay, press shift first.
that U and D via parabola.
Like in the graph. Yeah. In the graph, it was shift setup. What the heck? Press it.
And then we go into graph.
What's happening? Why is it hurting?
I don't know either. I'm not supposed to do that.
Try now. Derivative on.
What did you do?
Yours is different. I'll have to help you on your own. Okay, guys, type your equation in. This is what I'm waiting for. Okay, yours isn't graphing.
Mine says
Do it. That one won't graph. So.
Mine says invalid dimensions.
Okay, so you probably have one of your plots highlighted. Okay, 83s and 84s. Yours is a little different too, but it's Alright. So go to your graph, 83s and 84s. Oh my gosh, you guys. I know, but I pointed to it like 4 times. Parabola's equation.
I have an H.
Okay, like that.
Terminal. Yeah. Okay. Yeah, the only way it's going to be grabbing a vertical line is if you get something wrong. So go second one. Where the program. And clear draw. First one. I'll go back. Have you, like, what have you tried? Okay, I see an x equals up here.
We should just leave like 1 minute early. Just ask them to last.
Okay, in the future, if I don't know what that was, I would have cleared my memory, girl. You guys, this is taking too long. You gotta keep up. Okay? So, you guys, if you have an 83 or 84, do you have your equation typed in?
Yes.
You have a Casio, did you turn on your derivative, and then now you have your equation typed into your graph mode? Yes? Okay, so my 83s or 84s, you're gonna press second trace
Is it value?
6. Yep. And now type in the value we wanted, which was 5, and then enter. Okay, so 83s and 84s. Second, trace, 6, value, enter. Casios. Okay, you're gonna go press your trace button. Press your trace button, Casios. Now just, so you have, what is it? Shift F1. Now 5, enter. Shift F1, 5, enter. That means you have some of your plots on.
Whoa!
Usually.
That's cool.
Invalid, is it invalid dimension?
That's what I mean when I read stop plot that's on. It fixed it.
Oh, okay. Where's like
Yeah, I'll steer
I
something.
wonder if it's because it's not in your window. You gotta make your window, like you can press Zoom 6 to reset it. Did you get it? Yeah. So 4. Good? You get it?
I actually don't wonder what noise you're
Hey, I'll come around and help calculator issues. That's just to check your work. Do you notice how it's not doing the algebra for you, but tonight when you do your practice problems, it's a way that you can see if you did your algebra right. There? Now, here's what I want you to do, while I walk around and help calculator issues, is I want you to try it again. We're actually going to do the same function for time, but I want you to try it again, okay? But we're going to do exactly like what I want us to do on our homework tonight. So we're going to start by estimating the value, then proving the value with algebra, then checking with our calculators, okay? So this time, let's do here at 2. So give me an estimate.
That looks like
-2?
Yeah,
Okay,
-2.
let's do it. So here, okay, again, I'll walk around and help calculator issues. I'm just going to help you with the function composition step. The only thing we're changing is not the equation, but the a value, right? -2, thank you.
Wait, -2?
No, it's 2. Our estimate was -2.
So
the point.
okay, I'll
The
take
a value is the x coordinate. Yes.
Why are we putting twos?
And we're guessing that the slope there, the
We're
IRC.
guessing our answer, the IRC, is going to be -2.
It's like when we guessed that the IRC was 3 and then it ended up being 4. It's pretty dang close.
Yeah, that's a great
What does
estimate.
IRC mean again?
Average rate of change.
Oh, IRC, not ARC.
IRC is instant.
Instantaneous rate of
So
change.
it's at that moment, right? So if I'm going 60 miles an hour,
At where are you when the cop has the speed gun?
if I was graphing,
Right? Does the cop care what you're at the second they run their speed gun, or do they care if you were not speeding most of the time? Right?
Second you.
It's the second they run the speed gun, right?
So wait, did they use it?
Oh yeah. Hey, did you guys have any calculator issues? You're gonna, is it graphing? You're gonna need to get one eventually.
Where would I do that?
If you want to rent one from the school, you just do it at the finance office and go to Mr. Warner. Did you get it to work here? Did you turn your derivative on? It's then you go shift trade. It's pretty different on this one. You don't have to do it, but
Our estimate's -2.
and then press not as loud, right? And then that's gonna change to derivative. And then okay, are you guys trying this one now? Did you guys have calculator issues?
Oh,
Yeah? Well, then help your friends. Don't, yeah. Okay, did you guys have calculator issues? Yeah. How about yours? Did you get yours?
I'm looking forward to this already.
Okay, let me help.
Okay, so I just did my second help, right?
Yep, and then go down to the sixth one down, which is the RDX.
Press enter.
Now type in the number you want to know about. So we did 5 on the last one, so 5, and then enter. And then right above it, it says dy over dx is 4.
Okay.
So it's just, it won't do any of the algebra for you, but I just thought then I can give you a way that you can like feel more
So
confident
at that
after
point, the instantaneous rate of change.
it's 4.
Thank
Yep.
you.
Did you want me to figure yours out, or did you get it?
I figured it out.
Yeah?
Oh, it is? I did figure it out.
So
Oh, I did. I thought you said I'll do the algebra.
I guess so much through it. He's doing it so fast.
But, bruh.
No,
You get home and
because
negative
you're-
one-handed, you're not calling me because you weren't doing it in class.
Okay, I mean,
You plugged it into your calculator.
Here, you
Okay,
trying?
I call when A, when there's 2.
Hey, did you figure it out how to do it on here? Okay. Guys, trying this one? We gotta do one more family of functions, so I need you guys to get through this one quick.
No, this is for all functions.
Yeah, but we're just practicing a parabola. But I just assumed you guys would need some review on other types of functions. Have you checked your answer in your calculator?
Yeah.
Where's your
Wait, do you know what FX is? Oh, it's the same
Yeah, so
Trying
that's,
the next
it's
problem.
the same equation, we're just doing a different point now.
So same equation, but we're trying it too.
Dude. What an absolute guess.
Did we get it?
We did.
Hey, you figured it out too.
Do you want lotion?
It's killing me.
Yeah, we're gonna practice getting it on
I have to use like that.
Like a petroleum-based thing.
No, that's okay.
Is it Vaseline fix everything?
Oh.
I love the description.
Oh, prescription Vaseline.
Okay.
We're fancy.
What do you get for when you distribute?
And for the red pen again. Oh boy.
The reason I added
Are you guys new problem? Oh wait, oh you're just on.
Yeah, I'm just going through the steps here for time. Because we have to get through our rational functions before class ends.
Oh,
And the math is just different for that one, so I want to go slower through that
math
than
is
this.
always different for rational.
Oh, yeah.
How did everything else cancel out?
H minus
Yeah.
and negative 1 y.
Wait, but then there's also these. Well, there's also the 2H.
Do you want me to show you the box? I
Oh,
can.
so if you put the 4 on.
Box or arrows?
Oh.
Wait, so would you like do our math on?
What? Go back to
Why do you have two negative H's?
Box or arrows is giving the same energy as shake it or stir.
Oh no, because it's negative 1 plus H and then negative 1.
So this
You're not
parentheses here is
multiplying
next.
it. Wait.
Oh,
I
I'm
mixed it up. I
multiplying
mixed it up. Okay. That's right.
Where did I miss my negative?
Like, let's just say like a 10. I love this one.
I love
Oh, you guys are on it with your estimates, man. This is great.
Your factor is different than what I did. I've always seen the box method, but I've never actually used the box.
Oh, you can do arrows. I did arrows on the as an example on the last
Oh, I don't
one.
do arrows. I
I
do
love
the
arrows.
chart where it's X and Y.
You're thinking factoring. I'm distributing. What you're thinking of the chart thing is if I gave you this and I wanted this. I'm doing the backwards one. Okay. Okay, you guys, I'm sorry to speed through it on this one, but I want to get through one other type that's not parabolic before the bell rings.
I'll keep figuring it.
But walking around, about half of you were pretty right on the. either saw the right answer or you were like,
On the right track.
yeah, you just messed up in your foil or you're distributing here. That's where, this is the step from here to here. So distributing is where most of you are going to make your mistake. Okay, so just go slow, go real slow. Okay? Okay, any questions before we do a rational function? Are we okay? Okay. So, we're going to do the process again. This is the same process I want you to do for your homework tonight. I already sent it out, like 3 equations with 3 A values. I also noticed when I texted them out, they didn't look very good, so I typed them up with like an equation editor on Canvas. So you might want to use the one on Canvas.
Are those the only problems you sent out? I thought you texted out for whatever A3.
Yeah, so that's because I teach the 8A first, right? So those will be your homework tonight. Okay. It's only 3, but I mean, look, we've only done 2 in class so far. So.
Takes a minute.
Yeah. Mhm. Okay. So now we're gonna try a new f function here. So I'm gonna give you the function.
Oh,
Oh, I forgot my graph again.
Wait, we don't have to do this one right now.
No, we do. I mean,
Just a second.
unless you don't want me to go through an example of it before you try one on your
I'm
own.
just kidding. Let's do it.
You do. Let me just tell you. Okay, so let's take a guess first at f prime of 3.
F prime of 3.
So that's like around right here. So what's your estimate?
1.
Try again.
1/2.
It's definitely a decreasing line. Negative 1/2? Okay, that's all right.
That's what I was thinking.
Okay, so then now we can't find an exact derivative without the equation. So here's our equation. Okay?
So in the homework, will it give us the equation?
Sure does. And it gives you the A value. So I want you to do exactly what we've done in class each time. You're going to estimate, graph. You can graph with your calculator, estimate, then prove with algebra, then check your work with your calculator. Okay? So we're going to do 3. So this is f of 3 plus h and f of 3 minus h.
Whoa, that's glorious. What about the F?
That is f. 1 over x.
I'll see. Oh, okay.
Do you guys want, maybe you need to see this again?
Oh, okay, I see.
Now in unit 1, our main thing,
Yeah.
our main way to get rid of the whole was factoring. The last 2 examples we just did, our main thing was kind of a PEMDAS, right? Distributing, combining like terms. But right now, we have way too many fraction bars going on, right? So when I see way too many fraction bars, what should be my go-to math method? Common denominators. So we're going to take and multiply by 3 minus h over 3 minus h, and then 3 plus h over 3 plus h. I don't want to deal with the 2h yet. There's already too much going on. I'm going to pretend it's not there for a minute. Anyone have any guesses why I put that very top numerator in parentheses.
We did distribute the negative.
Yeah, I'm worried you guys are gonna forget to distribute the negative to both of those. So I just put it in parentheses.
Are we allowed to simplify that though in the bottom?
If you feel like you're ready. Well, oh, simplify. You mean here?
Yeah.
If you want to kill a puppy,
No.
you can't reduce that.
We'll reduce the bottom one.
Oh, foil it out?
Yeah.
Oh, okay. Sorry for the puppy joke. That's you can, but it'll be an extra step and won't need it at the end.
We don't.
It won't matter either way. If you foil that out or not, or distribute that out or not, it won't matter.
Well, I just kind of.
It doesn't make it wrong. I just sometimes wonder, we're already doing so much algebra that I worry if you make a little mistake on the factoring of it out. Sometimes I would rather you leave it in parentheses to avoid that. But
Care on the AP test, we like leave answers like.
they don't care how it looks, they just want it to be right. We're past the point in math where we care what the answer looks like. Hey, did I wait long enough? You guys good? Can I go to the next? What do you think I'm gonna do next?
We're gonna probably do this.
Before I combine like terms, I'm gonna distribute the negative. Okay? Okay, can I do two things in one step, or are we not ready for that yet?
Yeah.
I can do it? Okay, so I'm going to combine like terms, and then I'm going to keep, change, flip. Or flip and multiply, depending, I guess, on which elementary school you went to. Oh, I've got a fraction over a fraction, right?
Yeah.
So I need this to move up. What's something's denominator if I don't see it? 1. So I'm going to bring it up, right? And then combine my like terms there.
No, that's not my older brother.
Cancels out to be negative. Negative 1.
Hold on, let's wait. Most of everyone's still writing it down. They haven't had a chance to see the magic 2H up top and bottom yet, right?
Oh.
Oh.
Wait a minute.
Oh.
I got it.
Kid who sat
So how did that help us? You look. That just got rid of the divide by 0 error, right? So I'm ready.
I like how much room this takes up. It's kind of satisfying.
It's like a really fun Sudoku puzzle, right? Now I'm ready to make my H become 0. Because I just eliminated the divide by 0 issue, creating the whole. So by making the H 0, that's evaluating the limit. So now is the first time I can lose my limit notation. So I end up with negative 1, 9. Still not a bad estimate. But I'd like you for the practice to try and type it into your calculator here and just use that to verify. It'll just give you the decimal, so it should be what, negative 0.1111 or something, right? Okay, so next time in class we're going to move to derivative equations with the definition, but tonight we're just focusing at a point. So the calculator can help us check our algebra. Okay, good job, guys. Question? Here. Is there more time? Oh, you have to be given that. I did that. Or the book gives it to you. That has to be given. Yeah. Yeah, good? Yeah, you're like, it's algebra. You're pumped, right? Yes. Good job, guys. This was a tough lesson.